Hi, this session is on finding the length of a line segment. Now, sometimes instead of length, textbooks may use distance. So when they say the length of a line segment or distance of a line segment, it refers to the same thing. So just keep that in mind. And it's important to understand what we mean by a line segment. Basically, a straight line is technically when both ends continue on forever and ever. So a line is where we've got two arrows at the end saying it's infinite, goes on forever. A segment is where the line stops on both ends. So there's one point where it stops and it stops at the other end as well. Okay, so this one here is a line segment. It's not a line because a line goes on forever and ever in both directions. If you have a line where it stops at one point and continues on forever, we call that a ray. Okay, you may remember this from last year, but keep in mind that a line segment, when you see the word segment, it stops at two points, okay, on both ends. So it doesn't continue on forever, it stops. Now, questions can be written a little bit different to this, but they're asking you for the same thing. So this question says, find the length of the line segment with endpoints, and they've given you 2 points. So to find the length of a line segment, you have to have the 2 endpoints. Otherwise, you won't be able to find it. You won't have enough information. Now, to get a visual understanding, you can plot these points on a graph, okay, to see what this segment will look like. So instead of me drawing it, I've got the diagram here. So as part of your notes, I want you to draw this segment on a graph, and you can see how the 2 endpoints, when x is positive 2, y is positive 3 here, and this point down here, x is negative 2, y is negative 1. And there's our line segment on a graph. And all we have to do now is find the length of this line, and that's pretty much it. Now, looking at this graph here, you can maybe calculate it yourself quite quickly. But it's important to understand how we go about doing this. Now, the reason why it's important to draw this and see it visually is we know that when we calculate the gradient of a line, we have to have the rise, which is in this part here, and the run. And the rise and run are very important when it comes to this, because when you show the rise and run, what shape do you have? You can see we have a right angle triangle, okay? And with this right angle triangle, we know that with the right angle triangle, if I have the length of 2 sides, I can find the length of an unknown side. Now, I know the line segment here, this blue line here, is my hypotenuse. There's my right angle and it's pointing to my hypotenuse. Now, if I know what my rise is and my run, could I calculate the length of this line here? Yes, I can. Now, we can calculate the rise and run just by looking at this graph here. So for example, the rise will be 1, 2, 3, 4, and my run would be 1, 2, 3, 4 as well. Okay, and I can use that to work out the length of this line here. Okay, so that's what it looks like visually. Now, we don't always have time to draw a graph and to work it out that way visually. That's where you have to use your knowledge. To calculate the gradient, when you're given 2 points, we can use this formula. Gradient is equal to y2 minus y1 over x2 minus x1, okay? And we label our points. So we've got x1, y1, doesn't matter which one you choose, first or second, and then x2 and y2. And it's good to label them so you don't get confused. Now remember, this here is my rise, and this here is my run. So with that line segment, okay, that you should have drawn, we had the 2 endpoints, okay? We are working out the rise and we are working out the run. And when we get the rise and run, we can then work out our hypotenuse, our C, which is our length of that line. And that's all we have to do, okay? So put in these points. So I've got my gradient, y2 is 3 minus y1, which is minus a negative 1, over x2, which is a positive 2, minus, I just realized I made a mistake. This point should be a negative 2. because I was going to end up with 2 minus 2, which is 0, which won't work out. So just fix that, please. You may have realized I made that mistake. It should be minus 2 and then minus 1. That was 1 point. Okay, so I'll put a minus here that I forgot to put. So we've got not that one. X2 is positive 2, and then minus x1, which is a minus 2. Sorry about that. All right, and I'll just continue it over here because I haven't got room. It's supposed to be an arrow. So m equals 2 negatives make a positive, 2 negatives make a positive. So 3 plus 1 is 4 over 2 plus 2, which is 4. And remember, with our example, our graph, okay, we counted it. Our rise was 1, 2, 3, 4, and our run was 1, 2, 3, 4. But like I said, you're not always given it a graph like this. Sometimes you're given 2 points, and you have to use that formula that you would have watched before. So please make sure you've watched this lesson. When you're given 2 points, how do you calculate the gradient without looking at a graph? And it's really easy. Just remember this formula, label your points, and you're done. Now, the whole point of this is we're not actually calculating the gradient. We are finding the length of a line segment. The gradient here for this line would be 1, but we don't have to show that. We're going to use the rise and we're going to use the run. They both happen to be 4, and we're going to use this now and place it into our Pythagoras theorem. So once again, if you remember, just quickly, there's our graph. Okay, so I've just quickly done my own quick sketch. There it is. So my line segment has, now I'm showing it as a right angled triangle. It has a run of 4. So this line here is 4, or 4 units, and it has a rise of 4 as well. There's my right angled triangle. Instead of C, I've put L for the length of a line segment. It's supposed to be an L, okay? And now with Pythagoras' theorem, so we're going to find the length of this line now using Pythagoras' theorem, and that's it. So we know we've got c squared equals a squared plus b squared. And the easy thing is, when finding the length of a line segment, you're always finding the hypotenuse. So you're always trying to find c. So it's pretty easy. Now instead of c, I'll put L, so L squared is equal to, a can be 4 squared and b can be 4 as well in this case. We know it doesn't matter which one's A, which one's B, but it's important that your hypotenuse is correct. And now we've got L squared is equal to, well, 16 plus 16. Then L squared is equal to 32. Okay, now we know the next step, we square root it, cancels out, square root it. So the length, I'll just finish it up here. The length of this line segment is the square root of 32. Now the question didn't tell us to have it as an exact answer or an approximate. So most questions should actually tell you that. I forgot to put that in myself, sorry. Now, if it said to find the exact length, you stop here. That's the exact length in square root form. But of course, because you know how to simplify your surds, you can then continue to simplify. Is there a perfect square that's a factor of 32? Well, I know that 4 times 8 is 32, but also that 2 times 16 is 32. So I'll use that one because less working out. So the highest perfect square that's a factor of 32 is 16. So 2 times 16. And then I've got the square root of 2 times the square root of 16. And the square root of 16 is 4. So we're left with, the length would be 4 square root 2. That's in simplified form. Okay, that's what I want you guys to do because you guys know how to do that. But if it's an approximate, so that's an exact answer. Approximate, you push the square root of 32 into your calculators. And I've got 5.6568. The question should tell you to round it off. Just say it said round off to 2 decimal places. Well, I'll have the length is approximately, so squiggly equal sign, approximately equal to 5.66, and that's approximate. Okay, so that's the approximate answer. That's the exact answer. If you stopped here, it's still correct, but to get more of an A grade level, I expect you to simplify your surd because you guys know how to do it. Okay, and that's all you have to do. That's how you calculate the length of a line segment. Okay, so remember, you're using Pythagoras and using the rise and the run. So when you're given 2 points and not a graph, you use that formula y2 minus y1. And just when you do this next year, you actually be given a formula, and it looks like this. Now, if you want to, you can actually use this formula. It basically, instead of length, they use distance in year 10, but I'll put length because this year we're using length instead of distance. And basically what it does, it combines your gradient formula, the rise and the run, and starts Pythagoras for you. So if you want to just use this formula, you can. Just put in your x2 and x1 and so on. It doesn't matter if you have the x's first or the y's first, but for some reason the formula always has the x's first. So I've just got it straight from the textbook, but it doesn't actually matter which one's first. And also I forgot to put the squareds here, so please make sure you put the squareds there. That's better, square root. So basically they've started Pythagoras' theorem. So instead of L squared, they've got the square root there, okay? So instead of C squared, they've got the square root all ready to go. And in the brackets, it's your rise, this one's your run, and this is your rise. So you can use this formula if you want to. If you want to do it the other way, where you're just doing it step by step, that's fine as well. But this is actually useful, and you'll be doing it next year. Thank you.